For our first section, we are going to be comparing arithmetic and geometric. So on section A, you'll notice the top section wants us to do an arithmetic sequence. The bottom one wants us to do geometric. So we're going to do two separate ones. This top one, arithmetic, means they want us to add. So 4, how do I get 4 to go all the way to 324? Yeah. Add 320, but I need to split it into 1, 2, 3, 4 jumps. So I'm going to divide it by 4, which gives us plus 80 plus 80 plus 80 plus 80. Then I can fill in 4 plus 80 is 84. 84 plus 80 is 164. 16, 17, 18, 19, 20, 24 with a 4. 24 plus 8 is 32 with a 4 at the end. Does it make sense if I say that you divide by the number of blanks plus 1? Number of blanks plus 1. 1, 2, 3 blanks plus 1. There. Then it's a little side note in case we need it. The explicit equation would be, I'm going to fit it over here. F of x equals 4 plus 80 times x minus 1. Yes.
Divide 324 by 4, right?
To get the 320? To get the 320? Oh, are you going to the next section?
Yeah, sorry.
Oh, no, you're good. Okay. So, yeah, let's talk about geometric. Geometric is multiplying. So, you were correct. The first step, will you tell me again what you were saying to do for the first step?
Divide 324 by that.
Yeah. I start with division on geometric. Whoa, that should be a 4. I'm sorry. 4, sorry. When we're doing geometric, we just start by dividing, which equals, let's see, 2, 4, 8, 16, wait, 4, 8, 81?
Oh, I was just doing it in my head.
What did you get?
I was just doing it in my head.
I think it's 81. Will you check me and see if it's 81?
Yeah.
it is. Okay, thank you. Perfect. Then, my second step is I put the 81 in a root, but I have to find the number that goes on the root. So I'm going to count 1, 2, 3, 4. So there are 3 spaces plus the 1 at the end to get to the 324. Bless you. Which gives us a 3. Each time it multiplies, by 3. That would be the ratio. Fill in the blanks. Bless you. 4 times 3 is 12. Times 3 is 36. Times 3 is 108. The explicit function would be I start with 4 times by 3, and then I'll put a power of x minus 1 because I picked the first number in my list. On your assignment, you'll only be doing one or the other. You won't be doing both like this one is. See how they're both in the same table? They'll give you different sets. Cross off B. You're going to skip it. And we are going to go to rewrite each of the square roots below by removing repeated factors from under the square root. We are going to factor each number and then pull out whenever there are 2 that match. So does anybody know what times what is 8? 4 times 2. Good job. 4 times 2. Can you break down the 4? What would the 4 break down to? 2 times 2. And I can't break the 2 down anymore, so I'm going to drop it down in with it. Because this is a root with no number on it, you are looking for pairs. 2 pairs. So you need 2 of a kind. Because I have 2, they get to leave and go outside. When they leave together, they become 1. So it would be left as 2 with a 2 inside left over. That would be simplified. Let's try 75. Can you divide 75 by 2? No, it gives you a decimal. Okay. You divide by 5. Yeah, 5 does. 5 times what? 15. Good. Now 5 can't break down, so I just drop it down there. Just gonna slide it. And what is 15 factor 2? Which numbers get to leave that root? Why? 5s get to leave because there are 2. And the 3 has to stay. So I'm going to take the 5 out, but the 3 has to stay in the radical. Has anybody tried to break down 63 by 2? So like you can use your calculators. If you have a hard time with multiplying, just do 63 divided by 2. See how it's decimal? I'm not going to use it. What else could I divide 63 by? 3. I'm going to try 3. 3 would be 21. So when I divide by 3, it's 21. The 3 can't divide anymore. It's a prime number, so I just drop it down. 21, though. Who thinks they know what 21 is divisible by? 7? Let's try it. 7 and 3. The 3 gets to leave the radical, and the 7 is left inside. Okay. 98. 2? Okay, let's try it. 98 divided by 2, whoa, it's not divided, is 49. Two can't simplify. 49 is a perfect square. 7. Good. 7 times 7. So they would get to leave, and the 2 would be left inside. Okay, I'm gonna add one, just in case this happens to you. The square root of 36. There are 2 ways to do this. There are 2 ways. Okay? Does anybody know what's special about 36? It does. It's the square root of 6, which means it is 6 times 6. It's a perfect square, which means the 6 would leave, and would there be anything left in the root? Nothing. Everything gets to leave. The root is no longer there. So it would just be 6. Okay. Did anybody divide 36 by 2? Anybody divide 36 by 2? Would you try it? Divide by 2. See if it's divisible. Yeah, what'd you get? 18. All right. Now, 2 wouldn't break down, but 18 would. What's 18 broken down? 2 times 9? All right. What does 9 break down to?
3 times 9.
Okay. Sometimes when we break numbers down, we will have groups where there are more than one number that can leave. Now, because there are 2 2's, the 2's would get to leave, and the 3 would get to leave. I will multiply them together, which would give us 6. So I can use perfect squares, which is a little bit shorter, or I can just factor it, take out whichever ones have pairs, and I still get the same answer. All right. Okay. Perfect. Let's go to the new material. We have growth tables where it is tripling each year. So from 3 to 9, it is timesing by 3. I can continue my pattern, but I would have to go to here and here and here. I would have to skip the fractions for now. So if I continue, times by 3 is 27. Times by 3 is 81. Times by 3, 8 times 3 is 24, 243. The fraction sections are more difficult. So in order to fill those in, I'm going to build an explicit equation, which we have done before. It would be f of x equals 3 or 9 or 27, 81, or 243. which number from the list, I would usually pick one of these that we're giving. Do you want to use the 3 or the 9? You can pick, does not matter.
3.
You want to use the 3? Okay. I have a 3 as my 0 term, 0 year. It triples. Then I have a power of x minus 0. Okay. Now, when I fill in the half, I'm going to do 3 times 3 to the power of 1/2. Does 1/2 minus 0 change? No, so you can even drop that off if you wanted to. So I'm going to see what it equals on Desmos. What happens when I have 3 times 3 to the power of a fraction? It gives me this decimal. You may choose, okay? You can type in your box. Oh, that's not what I wanted to do. 3 times 3 to the power of 1/2, and that would mark it correct within your assignment. What's the other way you think your computer would allow you to type it in? I can enter it as this, or I can enter it in as a decimal. So you could pick. I can type this or 5.196152423. Why do you think I would pick that way over the decimal way, personally? I think it's faster, yes. So, who thinks they know what I would type in right there? Do you have it in your head what you're thinking what it should be? I'm going to write it and let's see if your idea matches. Did yours match? All right, let's fill in the next one. I would have 3 times 3, but instead of putting my power, I'm going to put 5/2 up there. Up in the power, so it should be up. Right. Are we ready to try? Ready to try B? Who thinks I could do B on their own? Yeah? Why don't you try it on your own? Try B on your own, and then I'll do it with you, and we'll check and see how we did. It'll be similar to A, right? Where we get to use our equation. Fill it. all the fractions should be with decimals, that's right. Just write it. All right, I'm gonna start filling in. I am growing by a factor of 4, so that says times by 4. 8 times 4, 32. And there are no other whole numbers, so I can't fill in those. I will now build f of x is equal to 2 times 4 to the power of x minus 0. Minus 0 won't do anything or affect my power, so I could actually just write it without it if I wanted to. So to fill in, I'll have 2 times 4 to the power of, I plug in, 1/3. This one would be 2 times 4 with the power of 2/3. 2 times 4 to the power of 4/3. 2 times 4 to the power of 5/3. It's kind of repetitive. And then you would submit. And this is so we don't have to type in super long decimals. It's to save us time. Any questions? Yes, Sam?
Do we have to use the 0 value? Or could we have used like 8?
That one?
Yeah.
Mm-hmm. Yeah, so if you do that, what if I use 8? Okay. It would be f of x equals 8 times 4 to the power of x minus 1. So the only thing you would change is in your power, you would have to have, so if I had 1/3, I would write 8 times 4 to the power of 1/3 minus 1 in the power. And then I would submit. If your computer drops the 1 down, so like if it does the 1/3 and then the minus 1 is big and down by it, just highlight it and have it power, move to the power. So it's up there. Good question. Any other questions? Turn the page. Our last one is reviewing exponent rules. They have doubled up. They are a little bit meaner. There are a few different ways you could do this. For F, does anybody want to share one of their ideas on what we should do first for this one? What do parentheses mean I do? Multiply. So if I multiply this in, I would have x to the 2 times 5 is 10. 3 times 5 is 15. Now, when they're side by side like that, the parentheses are now gone. I would now add them. I have 10 of them and 15, which is a total of 25. That would be my answer. What if I added these together first? What's 2 plus 3?
5.
Double check. 2 plus 3? 5. And then I would times it by 5, which would give me 25. The rules do not have to go in order. You could add them first, then multiply it. Or you could multiply then add. You get the correct answer no matter what order you go in. It's kind of fun. So this one, what would you like to do? Anybody? Do you want to put the 1/2 on each and multiply it, or do you want to combine the 4 and the -2?
Combine.
Combine? All right. If I combine, 4 minus 2 is what? Double check. Not -2. 2. So I put those two together first, which did not get rid of the parentheses because I was working within them. I was working within the parentheses. That's why they did not go away. Now I have 1/2 of 2. What is 1/2 of 2? Done. How do you want to do this one? Do you want to do the inside first? All right, inside first. -2 and a 5 would make a +3 when I combine them. I did not get rid of the parentheses because I didn't distribute the 6 yet. So there's still parentheses. 6 times 3 is 18. Done. Now they gave us letters. I'm gonna multiply this in first. I'm gonna do it this way, which would give me a x times z and an a y times z. So I multiplied it in. I distributed it because of the parentheses. Now I'm just going to add those two together. xz plus yz. And that would be done. Because I can't put any letters together. Bless you. Yes.
Did you just put like x plus y times z?
Oh, that's a good idea. Okay, let's do what you're saying. I'm going to do it one other way. Okay, so are you saying that you did x plus y first?
Yeah.
Okay, that works. And then you're saying you just multiplied the z to them. So if you do that, you can either distribute it and write it like this, or you could say z is multiplied by x plus y. You could choose. Both would be a correct format. Both are correct. Whichever one makes more sense to you, you can pick. Yeah, really good question. Let's go to G. I have 2x over, or sorry, not 2x, x squared over x cubed. I am going to,
It's the exact same thing.
okay, so I'll put it in, which is x to the 10th over x to the 15th. It's almost the same as the last one, but it's a fraction.
Oh.
So rather than adding 10 and 15, I'm going to subtract. I'm going to subtract these. What's 10? What's 10 minus 15? And because it's a -5, that means that the x should be left on the bottom. I skipped a step in my head. Do you want me to show you what that step was? So do you see how there are 10 on the top and 15 on bottom? When I do 10 minus 15, that gives me a -5. But I don't want a negative power. So do you remember where negative powers go to become positive? They have to switch. So because it's negative, that told me that it should be on the bottom of the fraction, because there were more on the bottom left over. There were 10 on top, 15 on bottom. So when I cross them off, there are only 5 left down here. Let's do this one the same way. What's half of 4? 2. What's half of -2? -1. Okay, so I cut those in half. Now, the negative power on the bottom, something's going to happen. Does anybody think they know what will happen? Negative powers have to switch to change their sign, which means it would now be up here. How many will that make if there's 2 and that up there? What do you think the total will be? 1 or 3? Let's check. I use the top minus the bottom. What is the top minus the bottom? A +3. So basically, I moved this one up to the top, and I said 2 and 1 make a total of 3. I'm going to distribute the 6 in. 6 times -2 is -12 over 5 times 6 is 30. Negative power, I would end up moving it down here, make it a positive, which would what would total up if it was a 30 and a 12 down there? 42. Let's check our work. I have a -12 on my top. I would minus the bottom. That gives me a -42, which is why when I write it, instead of writing z to the power of -42, I write it on the bottom as a positive. I'm going to distribute ax times z over a yz. I would subtract the top minus the bottom. Right. For h, will you rewrite h as x to the 5th over x squared? That's how it was supposed to be typed. It's supposed to look, but it was struggling with the word. How many x's total are on top? 8. How many x's are on the bottom? 6. Which means, where would the x's be left over once I cross off? 2 on top or bottom? Because there's more on top. So I would have x squared on top, and it would not be a fraction. It would only be a fraction if it had been bigger on the bottom. All right, let's rewrite this one as well. It looks a little weird. Y to the 4th, y to the negative 10th, over y to the 3rd. What's 4? What's 4 and minus 10 put together? Negative 6.
Charge Weber to the attendance office for a moment.
Thank you. So this becomes a negative 6. What happens when I move this negative 6 down with the 3? So it's now a positive 6. So this is what we're doing. We are taking it and moving it down. So it is now positive, which would be 6, 7, 8, 9. Y to the power of 9. I have z to the negative 2 and z to the 12th. That would give me z to the 10th over z to the 5th. Which would leave me with how many z's? 5. 5 z's would be left over. Would they be left over on the top of the fraction or the bottom? The top. The bigger numbers on top, that is where the 5 would be left over. So on these two, I'm going to add them up. Then I'm going to do x plus y has to minus the z, but I have to keep this as a whole, which would be written as x plus y minus z. Last one. Who remembers what power of 0 equals?
1.
1. 1. 1. 1. What if they have something written in red, usually above the problem, and it says, watch out, they're trying to trick you. What would 0 to the power of 2 be? 0. So whenever on your assignment there's like a red note, it's trying to trick you, so be careful. All right, you are good to work, and let me know if you have questions.